volts, the remainder amount of voltage then is always going to be getting dropped across my current limiter resistor. Then once I know what my voltage is, and if I know what my resistance is, so because now I know for this resistor, I know R and I know my V, I can figure out what my current's going to be. So I can figure out my current just by taking my voltage divided by my resistance, and I'll know how much current is going to be flowing through my circuit. So the resistor is always going to be our current limiter. That's going to be what's determining the amount of current that's flowing through our diode. The diode is always going to take its voltage first, and then the remainder is going to drop across the resistor. And these diodes can only handle a certain amount of current depending on what size they are. So when we're looking at this test setup, the test setup is basically this. This is what we have. So what we're going to look at is, so my voltage on my, so the voltage on my cathode could be my plus or minus 0 volts, and on my anode I'm going to have plus 0.7 volts. Okay, so when we're talking about diodes, if we're talking about a drop across a diode, the standard is kind of use the 0.7 volts. But you know, remember when we were talking about like in DC and AC that we always want to use our proper metric prefix in units. So it'd be the same as 700 millivolts. If you're talking about the diode itself and you just use 0.7, I'm good with that. Otherwise, if you put down 700 millivolts, I'm good with that too. Any other voltages, if I'm talking about the voltage drop across the resistor, I still want to see my, still see the 4 freaking digits. Some things just don't change over break. Oh, really? All right. So what we have then is that we're going to put up a voltage on this side, we're going to put a voltage on this side, and then we're going to determine whether if that diode is going to be a go or no go. So remember I said that the cathode is on is where the line is, and then this is the anode. For this diode to conduct, my anode has to be more positive than my cathode. And so what we always do then, another little rule that we always do now, and I'll ding you if you don't do it, is that to get familiarized with analyzing our diodes as we get into more complicated circuits, is what we do is we circle what we call the active component. The active component is the diode. Any type of semiconductor device is an active component. And then remember, resistors are passive. No matter what, whatever I do to the frequency, or whatever I change the current, the voltage, or whatever I do on a resistor, that resistance always stays the same. Then remember that we have our, what I call reactive components, which are inductors and capacitors. So if I change the frequency, my X of C or my X of L, my resistance will change on it according to the frequency. Remember that from way back when, about 4 weeks ago? Okay, so those are my reactive components. Then I have my active components. And these active components then, this resistance, this internal resistance of this diode, now we'll just call it, this internal resistance is going to be based on how much current is flowing through there. The more current I flow through this diode, the less resistance it is. And we'll talk about that as we go along a little bit. It becomes more of a, especially when we're talking about Zehners and stuff like that, where we can, another type of diode, we're going to talk a little bit more about that internal resistance of that diode. But so that's why we call them active components, is that because that resistance changes according to the current. So we always circle our active component. Then we also want to identify what the polarity of that active component is. So we know that my cathode is always going to be negative, and my anode is going to be positive. So we always circle the active component, then we just put the polarities in there. You don't have to put the letters or anything, but we just put the polarities in there. So this is going to help us identify whether if I'm more positive on my anode or more negative on my cathode for that diode to conduct. So now when we're starting to analyze this diode, this first diode, we show that we have a 0.7 volts on the anode side. And then on my cathode side, I'm at plus or minus 0 volts. So is my anode, am I more positive on my anode than I am on my cathode?
Yes.
Yes. And I'm more than that, and I'm also larger than, or I'm at the barrier potential of that 0.7 volts. Because remember here, I said that diode is always going to take its voltage first, and it's always going to drop 0.7 volts. It's going to take 0.7 volts to overcome that barrier potential. Anything less than that diode isn't going to conduct. It has to have that 0.7 volts. Once it starts to conduct at that 0.7 volts, current starts to flow, it's always going to drop that 0.7 volts. So yes, I'm greater than, I'm at my 0.7 volts, and I'm more positive on my anode than I am on my cathode, and that diode is going to start to conduct. And then that diode is going to become what we call a go. It's either going to be a go or no go, or failure. So that first diode is a go. So if we take a look at our circuit here, and we'll make this as our reference point. And remember my reference point, my test point, it's going to be plus or minus 0 volts is my reference point. And then if I bring out a test lead over here on my anode side of my diode, this is going to be my plus 0.7 volts. So that's what I'm looking at right here. I'm not looking at the full circuit, I'm just looking at what is my voltage if I had this test set up like this. If I got my red lead here on my anode side, my black lead on my reference, I'm going to measure a positive 0.7 volts. If I bring it down on the other side of the diode, I'm going to be at plus or minus 0 volts. And that's what we're doing right here. It's going to take at least 0.7 volts, well, right around 0.7 volts, that diode's going to start to conduct, current's going to start to flow, and that's at that point we consider it a go. Alright, any questions on that first one there? Believe me, I'm making this way overly complicated than what it really actually is, but until we get past that hurdle, this is like going, no, well, this is easy.
So those first three, are they all basically the same, or what's?
Nope, they're not all the same. No, I'm going to put in different voltages in there for you. Yeah. All right, so let's look at, we'll look at diode number 2. So the first thing that we always want to do is we want to circle our active component. Inside that circle, you want to put in your polarity. So I'm going to be positive on my anode, negative on my cathode. And then on this one here, I'm going to have a positive 0.7 volts. And on my anode side, I'm going to have plus or minus 0 volts. So then what the circuit looks like on this one, that's our diode 2. So that's what it's looking like right now. So I have plus or minus 0 volts on my anode side. I'm at a positive 0.7 volts on my cathode side. And if I circle my active components on my circuit here, positive, negative. And if I look at my circuit here, so if I look at my circuit here, the reference point here, this is going to be more positive than what this side is. So if I take a look, so this side is going to be more positive because this is a positive 0.7 volts here. This one's plus or minus 0 volts, so this one's going to be more positive. I'm more positive on my cathode side than I am on my anode side. So is that diode going to be a go or no go?
No go.
It's going to be a no go, and it's going to act like an open. And if it acts like an open, what am I going to measure for my voltage? My source voltage. Okay. So in this particular case, since I'm measuring 0.7 volts, that means that this wouldn't be an ideal thing, but that means that my voltage source would have to be at a 0.7 volts. That means my So I still have this circuit, my voltage source is set up at 0.7 volts. I'm more positive on my cathode than my anode. This is going to be a no-go situation. And if it's a no-go situation, it's going to drop my source voltage. This one is going to be a 0.7 volts going across there, but it's in a no-go situation because the polarity's backwards on it. Even though I'm still getting my 0.7 volts going across it. So this one's going to be a no-go, and current isn't going to flow through there, so it acts like an open switch. All right, then our next one. Okay, so the first thing I want to do is circle my active component, put in my polarities inside my, identify what my active component is for the polarities of the active component. Then I'm going to analyze it. Then what I want to take a look at is that, am I more positive on my anode than I am on my cathode?
Yes.
Yes. Then the next step I have to look at, now since I have two different voltages, am I at 0.7 volts greater to overcome that barrier potential? Did I make that 0.7 volts to get that current to flow through that diode?
Yes.
Yes. So this diode is going to be a go. And again, it's going to drop its 0.7 volts. And that's what the voltage difference is between these two. If I take the difference between a positive 1.4 volts and a positive 0.7 volts, the difference between them is my 0.7 volts. So I know that that diode is working correctly and it is a go. Okay? So that means that I'd have to have, I'd have another resistor here that would drop a certain amount of the voltage. This voltage here, I'd have to flip that diode around. I can try it real quick. So the circuit would look something like this time. This is sometimes the hardest thing, is just to understand what I'm looking at. If I don't have the full schematic, what am I looking at? That's the R1, the R2, so on. So referencing it to ground, my anode is going to be at a positive 1.4 volts. Referencing it to ground from here, this one's going to be a positive 0.7 volts. So again, because we do everything with our reference to ground, we're doing test point measurements. So if I put my black bead on my reference point, and if I bring up my red bead over to here, at this point here, I'd measure a positive 1.4 volts. If I bring it here, I'd measure a positive 0.7 volts. So how much voltage is being dropped across R2 then? Do I have enough information to figure that out?
Yes.
What's their source voltage?
I don't know, so what would be my voltage drop across R2 then?
0.7 volts.
What is it?
0.7 volts.
0.7 volts. Yeah, because if I bring my red lead down to my black lead, I'm going to be measuring whatever that is. This test point here is me measuring my R2. So R2 is dropping 0.7 volts. I don't know how much voltage is dropping across R1 because I don't know what my source voltage is. But R1 then would drop the remaining amount of voltage. So that's what this little test circuit would look like. It would look like a circuit, something very similar to that. Okay? So a lot of times when we're analyzing circuits, we don't see the whole picture. All we're getting is we might just get a device, and we're going to have voltages on each side, and we have to determine whether if it's good or bad according to our test point voltages. All right. Diode number 4 then. All right, so what's my first step when I'm analyzing diodes? Yeah, circle my active component. So I'm going to circle that active component, and then I'm going to put my polarities inside there. My cathode's going to be more negative, anode's more positive. Then I take a look. Is my anode more positive than my cathode?
Yes.
Yes, it is. And is it more positive by 0.7 volts?
Yes.
Yes. So is that diode going to be a go or no go?
Go.
That's going to be a go. So yes, I am more positive on my anode than I am my cathode. Makes that diode a go, and I'm going to be dropping the 0.7 volts going across there. So we know that diode's a go, and it's not a failure. All right. Okay, what's my first step that I need to do?
Circle.
Circle the active component, put my polarities inside there. Look at my polarities. So this side is going to be what? More positive or more negative compared to this side, my cathode side?
More
That's
positive.
going to be more positive. This side is going to be more negative. So is that diode a go or no go?
No go.
That's a no go. It's a no go, but it's still going to drop. It's still dropping its 0.7 volts, but it's a no go. All right. Okay, go or no go?
No, no.
Yeah, so I'm going to circle my active component, put the polarity in there. This one more positive or more negative than my, or is my, yeah, this one, I'm sorry. So is my cathode more positive or more negative than my anode?
Positive.
More positive. And my anode then is more negative, so my signs don't match up, so I know that I'm going to reverse biasing, and that was going to be a no-go. Still dropping 0.7 volts, but it's in a no-go situation. All right. Go or no go?
Go.
Or go, so.
Yep, that's a go. That one's a go. Go or no go? That one's a go also. I'm more negative on my cathode than I am on my anode. Go or no go?
Go.
Yeah, that one's a go also. I'm more negative by 0.7 volts than on my anode, so that's a go. And it's going to drop 0.7 volts. or no go?
No go.
No go. And what's my voltage drop across it?
0.
0. So if I measure 0 volts across the component, what's the problem with it?
Shorted.
Source
It's
open.
shorted. Because what do we measure across a short? Plus or minus 0 volts. So yeah, so this one is a no-go, and it's shorted. Because I'm measuring a voltage on, measuring the same voltage on each side. So it'd be like if this diode here was shorted out. At plus 5 volts here, and plus 5 volts here. If I have my red lead here, I measure 5 volts. If I bring it down to the other test lead, still measuring 5 volts. Then we know that that's just like a piece of wire in there and that's shorted out. So that's a failure, no-go failure.
You're not circling that anymore.
Saving this some time. I don't want to bore the crap out of you. We'll do it on our next worksheet though, we'll come back to it. Go or no go? Okay, so,
Or does that have to be exactly a point?
No.
yeah, now remember, it has to be that 0.7 volts. If that diode isn't dropping that 0.7 volts, then it's a failure. Okay? So, this one here is actually a no-go. And what type of, so let's draw this one up. So this one here would be, so that needs to correct. So this one here would be, and what would be measuring plus 5 volts. This one would be reading plus or minus. So that's what our circuit looks like. That's with our failed component in there. And then we know that my voltage source has to be, going to be my 5 volts. So if I bring my red lead over to here, and I'm measuring a positive 0.7 volts, all of a sudden I drop it down to this side, now I'm only measuring plus or minus 0 volts. I know that if I'm, or if I want to say it this way, if I go measure across my diode, and I'm measuring my source voltage, and I know that it's measuring my source voltage, then I know that that's going to be an open. And the reason why I know it's an open is because it's greater than my 0.7 volts. When that diode's good, it's going to drop 0.7 volts. Anything other than that is going to be a failure. Or it's just slightly below my 0.7 volts. So let's do this. Okay, so here's a good example where I would maybe want to draw a circle, circle our active component. Do it all through the whole step on our last one here. You know that this is. So is my cathode more positive, or more negative than my anode?
More positive.
More negative. Yep. Yep. This is more negative, and my anode is more positive. So is that a go or no go?
No go.
And why is it a no-go?
0.6.
Because it's only got 0.6 volts difference. Yep. We didn't overcome that barrier potential. We have to make sure that we're at that 0.7 volts before that diode's going to conduct. And once we get that 0.7 volts, then that diode's going to conduct and start going. So yes, this one's a no-go, and it's because it's only dropping the 0.6 volts. There isn't enough voltage to overcome the barrier potential. You'll see that in your lab there too when we're doing our diode characteristics curves of it. All right. All right, any questions on those ones? Well, I'm gonna still probably end this class at about 20 to 10 here, but let's take a 10-minute break there. I'm gonna make sure that I forgot to check up on that other student there to see if he got all registered and all. Now it's all taken care of.